my brick wall on the Morgan side of the family. So that was an example of analyzing a cluster prior to the availability of the WATO tool.
Odds. But let me turn to an example using a different cluster of my shared matches, and this is my Brennan cluster. And this is a cluster that is based on my Aunt Joan, who was born in 1921, sadly deceased, but she lived to a grand old age. And this particular cluster has 29 people in total. So here they are. These are the names of the various people in the cluster. I'm just using initials for privacy purposes. And you can see they come from a variety of different websites: Ancestry, 23andMe, MyHeritage, and even one from Family Tree DNA as well. Well, in fact, that's Aunt Joan herself. She's tested there too, or has her DNA on that website. There's 6 in Family A, who go back to the patriarch Patrick Brennan, born about 1822. These are all the matches in Family A, descended from Patrick Brennan. The matches in Family B, these ones here, indicated by the yellow, all go back to Daniel Brennan, born about 1830. And in the purple family, at the very end, Family C, we have the patriarch Joseph Brennan, whose descendants are these particular matches here. And you can see the year they were born, roughly, and the amount of DNA they share with Aunt Joan. Now, there's another very important point to make about this cluster, and that's the fact that there are 21 other matches in this cluster who match Aunt Joan, but they don't have a tree. There's no response when I message them. And they have amounts of DNA that they share with Aunt Joan between 20 and 139 centimorgans. 2 of them are over 100. 8 of them are between 40 and 100. So these 10, at least, could make a very valuable contribution to this particular cluster, but I don't know how they sit. I don't know where they are in relation to these patriarchs here. And the question that arose in my mind when I saw that we had these 3 families, Family A, Family B, and Family C, are the 3 Brennan patriarchs, are they brothers? Are they first cousins? Are they second cousins? Are they some other relationship? And is there a way that I could solve this using WATO, using multiple WATO analyses? And the first thing I did was go back to the records, because now I had a Patrick, a Daniel, and a Joseph. So do I find a Patrick, a Daniel, and a Joseph anywhere near my great-great-grandfather Patrick Brennan? And the first thing to note was Daniel Brennan, when he passed away in 1882, he was living at 4 Moore Street Market. And right beside him was my great-great-grandfather, Patrick Brennan, living at 3 Moore Street Market. And this is from records from 1880, from 1882, and from this death record in 1897. The other thing to note was this chap here was the informant, James Murtagh, present at death, 11 Rotunda Market. He was the son-in-law of Daniel Brennan, who was living next door. And a third piece of documentary evidence shows Mary Ann Murtagh, who was the wife of James Murtagh. And in 1913, when she passed away, again, the informant was her husband, James Murtagh, son of Daniel Brennan. But they were now living in the same house that had been occupied by my great-great-grandfather. So this told me that there were very close connections between these 2 families, between the family of Patrick, Family A, and the family of Daniel, Family B. And is it more likely that they were brothers, or first cousins, or second cousins? What do you think is the probability? I'm thinking somewhere in the region of maybe 60 to 70% that they were brothers. maybe 20 to 30% that they were first cousins, and maybe 10% that they were second cousins. So that's the kind of probability that I have in my mind, but of course, there's no definitive information from these records. But they do suggest to us, based on our experience doing family tree research, that maybe they're more likely to be brothers than not. Can we actually find any other information in the records to help us? And for that reason, I went to the church baptism and marriage records, church baptism records on the Roots Ireland website. And what I was looking for was a family with a Patrick who had brothers Daniel and Joseph. So I was looking for 3 brothers in the same family. And I would love to be able to tell you, bingo, there was only one family that had a Patrick, a Daniel, and a Joseph. And the parents' names were Octavius Brennan and Esmeralda O'Sullivan on each of the 3 baptism records. But unfortunately, this is not the case, and I can't tell you that, because it never happened. Instead, what we got were lots of Daniels and lots of Josephs and lots of Patricks. There was a Patrick and a Joseph baptized in St. Andrews, 1818, 1819, to a John and Mary Brennan. You couldn't ask for more common forenames. There was also a Patrick and a Daniel, born in St. Mary's, Pro Cathedral, in 1823 and 1834, to a Patrick and a Mary or Marianne. And there was a third family that had a Patrick and a Daniel baptized in St. Andrew's Church, to a Patrick and Mary, and again, very common names. So there was no family that had all 3 boys associated with the same baptism church where they were baptized, and the same parental names. So again, unfortunately, the documentary evidence was not definitive in terms of saying who was related to who. I'm thinking that this might be relevant, the St. Mary Pro Cathedral family, because that's where the children of my great-great-grandfather were baptized, because the Pro Cathedral was literally about 5 minutes walk around the country, around the corner from Moore Street, where they worked. So the records weren't terribly helpful, so I went back to contact my matches. And the reason why you contact your matches is because oftentimes they will have something that you don't. And this may be photos of your ancestors, family documents, Bibles, letters in the attic, stories and family lore, like we're related to the Morgans of Tredegar, extra generations in their family tree that you don't have in theirs, and of course you'll also have their line of descent, and you'll be able to see where they fit in. Some of them may have a very, very well-researched tree because they've been at it for 40 years, and I always love it when some people have a holiday home in Hawaii. And that's the place where I like to go and visit them, maybe for 6 weeks, and bring all of my genealogical data with me, and we can just spend our days on the beach doing genealogy. What could be better? One of the matches that I contacted, and this is a family tree of the Brennans, and just to show you who is who, there is my great-great-grandfather Patrick Brennan, and there is Daniel Brennan, tentatively put beside him as a brother in this family tree, and there is family C with patriarch Joseph Brennan, again tentatively attached to this draft family tree. And one of my matches was a granddaughter of this particular woman here, Frances Tremble. And this particular match, she said, my grandmother wrote down her recollections in 1949. And here they are. I don't know if you're going to find anything useful in them. Well, I did find something useful in them, because one paragraph in this typescript of her grandmother's recollections said, my mother's Aunt Dina Hart had 2 sons, Patrick and Ned, both of whom were butchers. Well, there's my grandfather there, and there's his brother, and they were both butchers. It said one of them had a business in Moore Street, and that was my grandfather, and the other in Parnell Street, and that was his brother. They both married and had large families, mostly girls. Well, my grandfather had 9 girls and 1 boy, and his brother had 7 girls and 4 boys. So everything in this was correct, except for the bit about my mother's Aunt Dina part. Aunt Dina would have been this person here, Christina Brennan, who incidentally had the same name, Christina Brennan, as this person over here. But this Aunt Dina was born in 1855, and her first cousin was born in 1870. So that is the only error that I see in this account from the 1949 recollections of my match's grandmother. She was not an aunt, she was in fact a first cousin, and probably the 15-year age difference made it seem like she was more like an aunt rather than a first cousin. So this was very useful documentary evidence, fairly compelling documentary evidence that Patrick and Daniel were in fact brothers. It didn't tell us anything about Joseph, but I'm now reasonably confident that Patrick and Daniel were brothers on the basis of this personal recollection from one of my aunt's DNA matches. And of course, this is the sort of information that you're not going to find in a library. You're not going to find it in an archive. It was something that was just held by the family themselves. So that's why contacting your matches can be very, very helpful. Now, the third thing that I can do with this cluster was to torture the data until it confessed. And this is where we get to the multiple WATO analysis. And the sort of question that I wanted to ask was, first of all, were Patrick and Daniel brothers? Because certainly everything that we'd seen so far, well, particularly the personal information from the one match, really pointed to the fact that they were brothers. And I also wanted to ask the question, were all 3 of these patriarchs, were they brothers? Patrick, Daniel, and Joseph, family A, B, and C. And in order to do this part of the analysis, we first need to generate a shared DNA matrix. And this is where we get into the real mad scientist area. So imagine yourself with goggles and even a cat with goggles. And to do this, we can do it using GEDmatch and using the cluster tool on GEDmatch, which produces something very similar to what Everjan Blom has produced on his Genetic Affairs website, because in fact GEDmatch has licensed in his tool to actually create something very similar on the GEDmatch website. And if we take, say, the first cluster here, and we just highlight everything in these boxes, highlight all the orange boxes, or more simply just highlight it in the legend, click on orange, it will automatically highlight all of the orange boxes, and then we, having selected the people that we want to put in to the multi-kit analysis, we click on the multi-kit analysis button, and it generates a shared DNA matrix for this particular cluster. So here you have the matches down the left-hand side, and also the same matches across the top. And what you're able to do is see how much DNA each match shares with every other DNA, every other match rather. And the interesting thing here is that you can immediately see that these 2 people here, they share 3,500. This has to be a parent-child relationship. These 2 people here, they share 371 CMs. This has to be either a first cousin once removed or a second cousin relationship. So you can see how just by looking at this shared DNA matrix, you're beginning to get a feel for how the various matches within the matrix are related to each other. And we can generate this type of shared DNA matrix from MyHeritage data and also from 23andMe data, because they allow a 3-way comparison. And by that I mean A versus B, A versus C, and B versus C. So let's take a look at that. Let's say my dad is A in this comparison, and he chooses one of his matches. Let's say it's Charles, who shares 492 CMs with him, we get an A versus B comparison. That's my dad against his match, Charles. But then if I look at all of the shared matches that Dad has with Charles, I can get an A versus C comparison. And that's my dad compared to the first of these shared matches. And we can get D, E, F, and so on. And that is very helpful. But what's extremely helpful is this B versus C comparison. This tells me how much my dad's first match shares with my dad's second match. And we can get a B versus D, B versus E, B versus F. And this type of comparison, which shows how much your DNA, your matches share with each other, I call that the B versus C comparison, and you do not get it on Ancestry, you do not get it on Family Tree DNA. They only give you, in effect, half of the analysis. You can do A versus B, C, D, E, F, but you will never know how much B shares with C, or C shares with F, or E shares with G. You'll never know how much DNA your matches share with each other. So that's why MyHeritage and 23andMe are particularly good for finding out how much DNA your matches share with each other. And this is essential for building a shared DNA matrix for each of your clusters. And the interesting thing about, the interesting difference between the kind of shared DNA matrix you can build using MyHeritage and 23andMe data and the kind of shared DNA matrix you can use using GEDmatch is that on MyHeritage and 23andMe, you are the base person, and it compares you to all of your various matches. And the base person is fixed, so it's only you that is and the matches that match you that are involved in this three-way comparison. But on GEDmatch, you can change the base person to absolutely any match in the other person's list of matches, and in their list of matches, and in their list of matches, and in their list of matches. So it gives you a much more comprehensive view using the GEDmatch tool, because the base person is not fixed, and you can do a round robin, if you like. If you get all of your shared matches around the table, you can move around the table and see the number and type of shared matches from every person's perspective, every single perspective around that table. What do you do if you want to build a shared DNA matrix using Ancestry, Family Tree DNA, and living DNA data? You have to ask each match in the cluster how many CMs of DNA do they share with every other match in that cluster. Talk about cumbersome. Alternatively, you can ask each match to make you a viewer of their DNA results so that you can actually see what their results show you. And that's only available on Ancestry. You can also ask each match to upload their DNA to MyHeritage so that you can do the three-way comparison yourself, or they can do it for you. The interesting thing about this is that matches cannot see how much DNA they share with people in other databases, unless, of course, they have a presence in those databases. So if they're only on MyHeritage, you're only going to see how much DNA they share with people in the MyHeritage database. So this is what I did with my Brennan cluster, and this is the ascendancy chart for my Brennan cluster showing the matches and their line of ascent. This is the shared DNA matrix that I was able to put together by using MyHeritage data and by asking people, can you tell me how much you share with all of these other people in the group? And the first thing to notice is the big question marks and the beige squares. There is a huge amount of missing data. And that really emphasizes how useful it would be if Ancestry offered this three-way comparison, this B versus C comparisons. You cannot get this with Ancestry. And if they did allow it and did exactly the same three-way comparison that's allowed with 23andMe and MyHeritage, it would mean that I could have filled in a lot more data on this shared DNA matrix. The other interesting thing to note is that even though there's 21 people in this matrix, 21 down this way on the left, 21 across on the top, only 13 of them span all three family groups, family A, family B, and family C. And the number of pairwise comparisons I was able to do when I was comparing A versus B, which is this square here, I was only able to do 31 pairwise comparisons out of a maximum of 66. For A versus C, I was only able to do 20 out of 24. Some of them were 0, which really didn't help at all. And for B versus C, I was able to do only 9 pairwise comparisons. So immediately you can see that my analysis is going to be severely limited and restricted by the lack of DNA data for a lot of these pairwise comparisons. And again, if only Ancestry offered these B versus C comparisons, we would have this data, because most of the matches are from Ancestry. Also, many of the comparisons are 0 or less than 20 cms, and that's 47% of the total sample. So I'm really trying to squeeze the last bit of juice out of the DNA before it disappears into the 1750s. And that also creates us problems, because with low amounts of DNA, the results are not going to be as reliable. Now, this type of approach it forms the basis for Everett-John Blom's auto kinship tool. And you can see in this example here, he's using amounts of DNA, 1,500, 1,700, 397, the 400s, much more substantial amounts of DNA than I am in my example. And it also forms the basis of what they do on 23andMe with your family tree. Again, they're doing multiple analyses and then plotting people in various positions that they could occupy within the genetic family tree. And I think as we move further into the future, this is going to improve, it's going to get a lot better, and we will have we'll have a lot more automation with this type of analysis. Now, the place to find the particular WATO tool that I'll be talking about when we do this multiple WATO analysis is on the DNA Painter website under the What are the Odds version 1 box, and it's the early prototype table version. And this was actually the first version of the WATO tool that Johnny Pearl developed. And it later evolved into something very, very different that is more useful for dealing with unknown parentage and finding where somebody sits in relation to a group of people whose genealogy is known. So you have a fixed family tree. You know that this particular person of unknown parentage shares a certain amount of DNA with the people in this fixed family tree, and the WATO tool version 1 is able to tell you the most likely position for the person in the family tree based on what we already know. But even before they developed that version of the WATO tool, there was an early prototype table that was more suited to the type of analysis that we are trying to do here. Are the three patriarchs brothers, first cousins, or second cousins? That's what we're trying to decipher. And this is the probability test tool, version 0.2. What you can do is you can add new relationship hypotheses. So in order to do that, you create different hypotheses. You hypothesize first that they're siblings, then you can add in half siblings, then you can add in first cousins, then you can add in second cousins. And you can add in a variety of different matches. You can do all pairwise comparisons, A versus B, A versus C, A versus D, B versus C, B versus D, and so on, with how many letters in the alphabet you want to. You have to put in the amount of DNA that they share in common and their relationship to each other if hypothesis 1 was correct, that they were siblings. Their relationship to each other if hypothesis 2 was correct, that they're half-siblings. Their relationship to each other for hypothesis 3, hypothesis 4. So you end up with a huge amount of data that has to be entered manually. And the problem with this is that there's a high risk of transcription error. But there's the approach, these pairwise comparisons, and then a compound probability, A versus B versus C versus D, E, F, how many hypotheses you have. And the science behind the tool is very well documented in Leah Larkin's wonderful series of blog posts called Science the Heck Out of Your DNA, and the link is there and also in your handout, in your syllabus. And this is the output. So here we have AJ from family A compared to BM from family B, AJ and Joan from family A compared to AW from family B, AJ versus VF and B versus POH and B, and all of the different members of family B compared to Aunt Joan. And after doing the various hypotheses, and you have hypothesis 1, 2, 3, and 4, let me show you what they actually were. Hypothesis 1 was second cousins. Start with the more distant ones. Hypothesis 2, first cousins. Hypothesis 3, siblings. Hypothesis 4, half-siblings. At the end of the analysis, when we crunched the numbers after clicking the Calculate Probabilities button, it says siblings is most likely, with an odds of 2,645 compared to the least likely, which is first cousins, which has an odds of 1. Hypothesis 1, which was second cousins, is actually, the odds are 0. It's been ruled out because of this one relationship here. Aunt Joan and MD from family B share 124 CMs of DNA, and that would make second cousins impossible because Aunt Joan and MD would be fifth cousins if the three patriarchs were second cousins. And sharing 124 is impossible for a fifth cousin. It is beyond the bounds of possibility. It is far too high, and therefore the second cousin hypothesis is ruled out. And that just leaves you with 3. First cousins, siblings, and half-siblings. And siblings is, let's see, first cousins is an odds of 1, half-siblings 500 to 1, and siblings compared to half-siblings is about 6 to 1. Well, here it is 5.15 times more likely than half-sibs. Those were the odds generated, 0, 1, 513, and 2645. So in this particular example, Aunt Joan versus, using Aunt Joan's results, family A and family B were likely to be siblings. So the patriarchs of those families were likely to be siblings. Patrick and Daniel were likely to be siblings. I did the same kind of comparison using my data, and of course I'm a generation younger than my Aunt Joan, so the amounts of DNA were a lot lower, and I even had zeros in there as well. This came out again with odds of 1, 3, 3, and 24. Siblings was again on top with odds 7.4 times more likely than second cousins or first cousins, who came in a joint second, and again, half-siblings came in with an odds of 1. So it's interestingly, in the previous analysis, second cousins were ruled out, but in this analysis, using my data, they haven't been ruled out. So again, it shows you how variable the DNA can be and how variable the output can be based on the DNA that you put in. This is the same analysis, family A versus family B, using my brother's data, and my brother was very different to me. He didn't have a match with some of these people at all. And those generated wildly different odds ratios, 1, 3, 16, and 16, and strangely, second cousins came up on top. So again, we're dealing with a situation where if you're putting in very low amounts of DNA, the results might be highly unreliable. I then did a compound analysis using Aunt Joan's data, using my data, using my brother's data, and using another cousin's data from family A, comparing all of those with family B. I'm putting them all into the same analysis, and this time siblings came out on top yet again, about 10.7 times more probable than the next most probable relationship, which was half-siblings at 33 to 1, and hypothesis 1, which was second cousins, was again ruled out, again because of that relationship between Aunt Joan and MD in Group B, Family B. And this was the second page of all of the comparisons, the multiple comparisons, myself, my brother, and this fourth person in Family A. So there were altogether maybe about 30 comparisons that were put into this particular compound WATO analysis. And at the end of that, the siblings hypothesis is probably the most likely on the basis of Aunt Joan's data with odds of 5 to 1, my data with odds of 7 to 1, and a compound odds ratio of 10 to 1. But my brother suggested that siblings were least likely, but then a lot of his comparisons had a value of 0 for the amount of CMs shared. So that was the WATO analysis comparing Family A with Family B, Patrick with Daniel. We conclude from this that the multiple WATO analysis supported the idea that Patrick and Daniel were brothers. But again, there's a caveat that it wasn't consistent across all of the comparisons. We then turned to a comparison between Family A with Family C. Family A, the patriarch is Patrick, and Family C, the patriarch is Joseph. And we did the same kind of analysis, the pairwise comparisons between Aunt Joan and members of Family C. And again, the amount of DNA shared was relatively high. And again, siblings came on top for a comparison between A and C. So Patrick and Joseph were suggested to be siblings by this analysis. But look at the odds ratio. It only reached 1.7 to 1. So it was barely above the threshold of unity. And this is not very, very convincing result. And again, two hypotheses, second cousins and first cousins, were ruled out on the basis that if Aunt Joan and AB from Family C were fifth cousins once removed or fourth cousins once removed, it was impossible that they would share 111. So hypothesis 1 was that the patriarchs were second cousins, hypothesis 2 that they were first cousins. Both of these hypotheses can be ruled out. The same analysis, Family A versus Family C using my data, the DNA is a lot less, and again, the probabilities, well, 3 of them were exactly the same. So there wasn't any major differentiation in this particular analysis, and even doing a compound analysis of everybody in Family A compared to everybody in Family C, 20 pairwise comparisons, half siblings came out on top with the odds of 97 to 1. And the hypothesis for second cousins and first cousins were ruled out. Again, probably on the basis of that, on that single comparison between Aunt Joan and AB from Family C, who shared 111, which would have been impossible if the patriarchs were second cousins or first cousins, because then that would make Aunt Joan and AB fifth cousins once removed, or fourth cousins once removed, and that is impossible for an amount of DNA of 111 CMs shared. But really, in this comparison between Family A and Family C, there was no overall consistency in the analysis, and the results are questionable. The last analysis was a compound analysis between Family B and Family C, only 9 pairwise comparisons, and the odds generated were 1, 3, 3, 3 for the various hypotheses that you see here. There's 1 for siblings and 3 for half-siblings, first cousins, and second cousins. Siblings were the least likely, others all equal, 3 times more likely, but 9 of the 44 possible comparisons, only 20% of the potential data was used in this analysis, and some of the data points were 0 or certainly less than 20. So you're dealing with very, very low levels of DNA, which makes the output unreliable, and we're not seeing a consistent pattern in this comparison between Family B and family C, and that would be Daniel and Joseph. So, to summarize, the multiple WATO analysis requires that all data has to be entered manually. There's a very high risk of transcription error, and I did it at least 3 or 4 times. There are glitches with this program, and the only way to correct those glitches is to press the permalink button. I know it sounds strange, but this is what I found. Press the permalink button after you have pressed the calculate probabilities button. So you calculate the probabilities by pressing that button, and then when the results come up, click on the permalink button, and you'll find that sometimes the output changes as a result. So that's another problem with this particular type of analysis. There are glitches in the program. Low values of CM shared will steer the conclusion toward more distant relationships. High values will help rule out the more distant relationships. And high values may be falsely inflated by hidden additional connections. So supposing, for example, my Aunt Joan was doubly connected to one of the matches that she shared a large amount of DNA with, then that particular value is going to be falsely inflated, because maybe she is a third cousin, but also she's a fifth cousin. And just that little bit of additional information, a little bit of additional CMs that she gets from being a fifth cousin is going to inflate the amount of DNA shared, and it's going to make the program think, well, that's impossible for that particular hypothesis, let's rule it out. So we could be falsely ruling out viable hypotheses because of hidden additional connections in the family tree. Torturing the data produces results that need to be taken with a pinch of salt. So it was a great academic exercise, but at the end of the day, we do need to be very careful about how we interpret the data. The results, however, are consistent with the notion that patriarchs A and B are brothers. But there's poor evidence for patriarch A compared to patriarch C, patriarch B compared to patriarch C. So at the end of this analysis, we can say that yes, the multiple WATO analysis supports the contention that Patrick and Daniel were brothers, but there's inconsistent or inconclusive results that all 3 patriarchs were brothers. So to conclude with this particular example, the cluster analysis shown in this ascendancy chart identifies these 3 patriarchs, Patrick and family A, Daniel and family B, and Joseph and family C, who may be siblings, half-siblings, first cousins, second cousins. The evidence from the documentary records, those death records that I showed you, that showed that Patrick and Daniel were actually living side by side, and their families were very intertwined because Daniel's brother-in-law was the informant on Patrick's death certificate. That documentary record suggested a close connection, but could not distinguish between siblings, half-siblings, first cousins, and second cousins. The personal information from a single match did provide strong support that Patrick and Daniel were brothers. These recollections from the 1940s from one of my match's grandparents was quite convincing in that regard. And lastly, the multiple WATO analysis generated odds of about 10 to 1 in the compound analysis that Patrick and Daniel were brothers. And the other important thing to point out is that in both of the examples that I've shown you, it was contacting your matches that provided the breakthrough that I needed to find out that I had an additional 23 ancestors above my warning line, and also that Patrick and Daniel. So look at this. It'll stop around in a moment anyway. was the least fruitful, and torturing the DNA was the very least fruitful. And that really concludes my presentation. The last thing to note, of course, is that there are 21 people that I could not assign to this cluster, and they could have been quite instrumental in improving the multiple WATO analysis. And lastly, if all the answers we offer to these B versus C comparisons, it would make life a lot easier for what we're trying to do here. So that concludes my presentation. And Jeff, I shall hand it back over to you. I know there's some door prizes to be handed out, and I will be very happy to answer any questions that people might have. Thanks very much for your kind attention.
Oh, thank you. Just fascinating, Morris, how you're using these tools. As you taught, I began to think of a